Hello friends, and today we are going to study numericals, which is a problem number 2 based on the solutions of differential equation in Laplace transform. In previous part, what we have studied, a numerical in which the three parts were asked. The first one is a transfer function, the second one is impulse response, and third one is step response. Now, as I told you, all the first three numericals are based on the same thing. So today's numerical is also based on the same thing, where in question it is asked impulse response, transfer function, and the step response. But in next three videos, I'm going to change the question. That is, in that I'm going to ask a question where you have to calculate output response, ZIR and ZSR. But we'll see later on. The first one is current question, that is question number 3. The first of all, most important one is question number 3. So we'll see the question number 3 first, and then we'll move on to solution. So the question number 3, a differential equation of a system is given as 2y dash of t plus 3y of t equal to x dash of t. Now look, just go through the question number 2, or you can say the problem number 2, which was solved in previous video. In that question, it is already mentioned the system was initially relaxed, but over here it is not mentioned. Means what? Here we have to assume the initial conditions are 0. Now what is asked? Determine the transfer function, step response, and impulse response where the x of t is equals to del of t is given. So we know that impulse response means what? While calculating impulse response, we have to consider x of t as a del of t. But in this question, it is already given, so no need to worry. Now we'll find out the first of all transfer function. But before calculating transfer function, look at here. Here we have to assume all the initial conditions has to be 0, because in transfer function we'll get only the current value, not the initial one. So we'll move on to the solution. Now the question was 2y dash of t plus 3y of t equals to x dash of t, and while calculating impulse response, the x of t is already given, which is del of t. If it is given, then also that doesn't matter. And if it is not given, then we know that x of t was, we have to take x of t as a del of t while calculating impulse response. Now, we have to find out the first thing, which was a transfer function. So, we are going to find out the solution number 1. Now, what is mentioned? Applying Laplace transform and assume all the initial conditions are 0. Now, the question is 2y dash of t plus 3y of t equals to x dash of t, and one thing is given, x of t equals to del of t, and it is for only to find out the impulse response. Now we'll find out the Laplace transform, because what we want, the transfer function, which is a question number 1. That's why I've written applying Laplace transform and assume all initial conditions are 0. Now just go through the properties that we have derived in Laplace transform. The property was differential equations or differentiation property. Now over there you will get the idea. The Laplace transform y dash of t is sy of s, Laplace transform y of t is y of s, and the x dash of t is x of s. Now I'm using the same statement and same formulas over here, so just look at here. Now you can take y of s common from left hand side. Now, as we know that the transfer function is nothing but it is the ratio of output by input, that is the Laplace transform output by Laplace transform input. So output Laplace transform, that is y of s, and input Laplace transform is x of s, or you can say Laplace transform output, which is y of s, and Laplace transform input, which is x of s, that we have already calculated. Only the thing is you have to shift this x of s on left hand side, and this is nothing but my transfer function. Shift this 2s plus 3 on left hand side. Shift this 2s plus 3 on right hand side. And this is nothing but the solution of part number 1. Now, what is our next step? We have to find out the step response, which means we have to substitute x of t as a u of t. Now, the second part was step response. We have to calculate the step response. But before moving to step response, you should know that first of all, apply input as a unit step, or consider input x of t as a unit step, and then calculate the Laplace transform of it. Now, x of t that we have to consider as u of t, and the Laplace transform of x of t is nothing but a Laplace transform unit step, which is 1 by s. Now, what is the next step? Is we have to substitute this value in equation number 1. Now, this was our equation number 1. Now, multiply this x of s on right hand side. And the x of s value was 1 by s that I have already directly substituted. Now, the next part is, you can say that this s and this s will get cancelled. So, what will be your result? Now, if you want, then you can take these 2 common from this part. So, if I take these 2 common from this denominator, then what you will get? Now, one more thing I can tell you, if you wanted to take these 2 common, then you can use the shortcut technique also. Just divide numerator and denominator by 2. Now, if you want to take a 2 common from this denominator, then I can suggest you the second one more method. Just divide numerator and denominator by 2. If you divide numerator and denominator by 2, then all these terms which is in denominator can separately divide it by 2. So, if you divide this 2s by 2, then 2 gets cancelled. The only part is s, whereas this 3 is divided by 2. So, answer is 3 by 2. In numerator, we have 1 only. So, 1 by 2 is nothing but 1 by 2. If you want, then you can write 0.5 also. This is nothing but your y of s. Now, what is important? Find out the inverse Laplace transform of it to get the step response. So, applying inverse Laplace transform, what you will get? The y of s is y of t, that half is written as it is. Now, look at here, this s is delayed by 3 by 2, or you can say shifted by 3 by 2. So, opposite sign value of 3 by 2, which is minus 3 by 2, multiplied with the t, which is in the power of e, and the last one is 1 by s, and it is nothing but a Laplace transform inverse is u of t. So, this is nothing but our step response. Now, we will calculate the impulse response, but over there in question it is already given x of t is nothing but del of t. So, no need to assume anything. The x of t is already given and it is del of t. So, we will move on to impulse response. Now, the third part is impulse response, and in question it is already given x of t is del of t. So, we will directly apply Laplace transform. Now, we know that the Laplace transform of x of t is nothing but x of s, but the Laplace transform of del of t is always 1. Now, what is given in equation number 2 that I am going to write over here? Now, y of s by x of s. Look at here. Here what we have? S upon 2s plus 3. Now, multiply this x of s on the right hand side, and the value is 1. So, after substituting value of x of s, that is 1, then this equation will remain as it is. Now, what is important? We have to find out the Laplace transform of s upon 2s plus 3. How to calculate? I'll show you. What we have to do, we have to calculate y of s. Now, in numerator, we have a s, and this will create some problem. Now, what to do? I'll do one thing. I'll add plus 3 by 2 and minus 3 by 2. Why I have added plus 3 by 2 and minus 3 by 2? You will get the idea. But first of all, let's see the result. Now, I'll take 2 common from the denominator. So, what you will get? If I take 2 common from denominator, or you can say simply just multiply it by half and divide by half, or simply divide numerator by 2 and denominator by 2. There are different ways to take it 2 common. You can say that divide numerator and denominator by 2, or else just multiply half and half in numerator and denominator. Well, I am going to multiply numerator and denominator by half. A numerator half I have already taken outside. Now, the numerator part is I have written as it is, but in denominator, if I multiply half in denominator, then what you will get? This 2 and this 2 will get cancelled, so we have only s, and this 3 is multiplied by half, so we have a 3 by 2. Now, we know that we have one formula, we have studied one, a plus b by c. You can write a plus b by c by a by c plus b by c. So which means I'm going to split this numerator part in two parts, like s plus 3 by 2 will be first numerator and minus 3 by 2 is my second, another numerator. Look at here. Both the terms are similar, so these two terms will get cancelled. Only the thing is minus 3 by 2 into in denominator s plus 3 by 2 will be there. So here we have 1 and minus, and this is nothing but our y of s. Now we have to find out y of t, which means we have to apply inverse Laplace transform on all this equation. Y of s was my half into bracket 1 minus into 3 by 2 into 1 upon s plus 3 by 2. Now what I'm going to do, I'm going to apply inverse Laplace transform both these sides. So y of t inverse is y of t. Half is a constant, so no need to worry. Now inverse Laplace transform is 1, and we know that the del of t Laplace is 1, so inverse of 1 will be a del of t. Here minus 3 by 2 is constant into, look at here, this s is shifted or delayed by 3 by 2, which means we have to use a frequency shifting property, and according to frequency shifting property, the answer is if s is delayed by 3 by 2, then we have to multiply input by e to the power minus 3 by 2 into t, where my input is 1 by s and the inverse of 1 by s is, we know that it is a unit step. Now, this is the result of impulse response. Now, all the numericals we have studied till now, which are based on transfer function, step response and impulse response. Now, the next coming 3 videos or 3 numericals based on output response, zero state response and zero input response. Now, that's all for now. We'll study next numericals in next video. So, thank you for watching this video. Stay tuned with Ekeeda and subscribe Ekeeda for further more videos. Thank you so much.